For solving rational inequalities, an inequality may have infinitely many solutions. The set of all solutions can be expressed using a set notation or interval notation. Remember our video lesson number 1? These notations are presented in the table. Solving rational inequality means finding the values of the variable which will make the inequality true. To solve rational inequalities, number 1, use addition or subtraction to rewrite the inequality as a single fraction on one side of the inequality symbol and 0 on the other side. One side must be 0 and the other side can have only one fraction. Simplify fractions if there is more than one fraction. Number 2, find the key or critical values, or we call this test points. To find the key or critical values, set the numerator and denominator of the inequality equal to 0 and solve. Number 3, make and perform sign analysis chart or table of signs. Use the test points in the intervals determined by the critical values and to determine the sign of the inequality on those intervals. Number 4, use the sign analysis chart or table of signs to determine which section satisfy the inequality. If the inequality is less than 0 or less than or equal to 0, then you want all of the negative sections found in the sign analysis chart. If the inequality is greater than 0 or greater than or equal to 0, then you want all of the positive sections found in the sign analysis chart. Number 5, use interval notation or set notation to write the final answer. Are you ready? We will do this E, B, S, B, S, T. What do you mean by that? Inch by inch, step by step together. Okay? Example number 1. Solve the inequality x squared plus x minus 12 divided by x minus 1 is less than or equal to 0. Okay, let's do step 1. Rewrite the inequality as a single fraction. It looks like the given inequality is already simplified as a single fraction, and the right side is already 0. Now, proceed to step number 2. Find the key or critical values or test points. Equate the numerator to 0. Apply factoring and solve for x. So this will be our step. That is x squared plus x minus 12 equals 0. Factoring this, we have x plus 4 times x minus 3 equals 0. So, our values of x are x equals negative 4 and x plus 3. This means that the rational inequality will be 0 for x equals negative 4 and x equals 3. If graphed on the number line, these values will be included and shaded circle will be used signifying that those values are solutions. Next, equate also the denominator to 0 and solve for x. So we have x minus 1 equals 0, therefore x is equal to 1. This means that the rational inequality will be undefined for x equals 1. If graphed on the number line, this value will not be included and unshaded circle will be used, signifying that it is not a solution. Step 3. Make and perform sign analysis chart or table of signs. We first lay down our number line with the corresponding critical numbers, negative 4, 1, and 3. Looking at our critical numbers, we have 4 intervals, values greater than 3, values in between 1 and 3, values in between negative 4 and 1, and values which are less than negative 4. Next, we choose one integer in each interval to be our test point. For values greater than 3, I choose 4. For values between 1 and 3, I choose 2. For values between negative 4 and 1, I choose 0. And for values less than negative 4, I choose negative 5. These chosen integers will be substituted to our rational expression one at a time to get the sign of the answer. We are not particular here with the answer. Only the sign is needed. That is why it is called the sign analysis chart. Substituting negative 5 to all x in our expression, negative 5 plus 4 times negative 5 minus 3 divided by negative 5 minus 1. Negative 5 plus 4 is negative. Negative 5 minus 3 is negative. Below we have negative 5 minus 1 is also negative. So negative times negative is positive. Divided by a negative, the final sign is a negative. Next, substitute 0, 2, and 4 to complete the sign of the remaining interval. Step 4. Use the sign analysis chart or table of signs to determine which sections or intervals satisfy the inequality. So going back to our rational inequality, which interval is less than or equal to 0 or has negative value? Based on the given, we are looking for the intervals where the rational expression is negative or 0. So you will get all the negative sections from the sign analysis chart. Negative signs is found between 1 and 3, and also all the values less than negative 4. So we have to thicken the number line to indicate that all values are solutions at these particular intervals. Step 5. Use interval notation or set notation to write the final answer. The negative sections from the sign analysis chart determines that the solution is the set. X are all the elements of real numbers, or all the domains are all real numbers, such that x is less than 4 or x is less than 3 but greater than 1. It can also be written using the interval notation, referring to the table of interval and set notation. We have negative infinity, comma, negative 4, union 1, comma, positive 3. Because 3 is included, we're going to put a bracket. We use brackets for negative 4 and 3 because they are included as part of the solution. 1 is open, so we use parentheses. And of course, infinity uses parentheses all the time. That's it. Done. We will have more examples and deepening in our synchronous class. See you there.